For this type of t-test, there are some new notations to learn. The letter D stands for difference scores. All the math we do for this formula is based on the difference scores, which is a column of numbers that we create when we subtract each one of our paired scores from the other. The notation shown on the bottom of the slide stands for the mean of the difference scores, or M with a subscript of D. And we calculate that by dividing the sum of the difference scores by the number of pairs of scores we have. For this type of t-test, we calculate N by totaling up the number of pairs of scores we have. Shown in Table 11.2 on the slide, which is also on page 316 in your text, is an example of a related sample study and shows how we lay out the data. What the data shows is reaction time measurement taken before and after taking an over-the-counter cold medication. The table presents hypothetical data from a research study examining how reaction time is affected by a common over-the-counter cold medication. The first score for each person, X1, is a measurement of reaction time before the medication was administered. The second score, X2, is a measure of reaction time 1 hour after taking the medication. Because we are interested in how the medication affects reaction time, we have computed the difference between the first score and the second score for each individual. The difference scores, or D values, are shown in the last column of the table. Notice that the difference scores measure the amount of change in reaction time for each person. Typically, the difference scores are obtained by subtracting the first score before treatment from the second score after treatment for each person. Another way to state that is we subtract the treatment group scores minus the control group scores. Look at the column of difference scores. Note that the sign for each D score tells you the direction of the change. Person A, for example, shows a decrease in reaction time after taking the medication, a negative change. But person B shows an increase, a positive change. The sample of difference scores, D values, will serve as the sample data for the hypothesis test. To compute the T statistic, we will use the number of D scores, N, as well as the sample mean, the mean of D, and the value of sum of squares for the sample of D scores. Shown on this slide is the formula that we use for both the related and paired samples t-test. In the numerator is the average or mean of the column of difference scores. In the denominator is the number that represents the estimated standard error for the difference scores. All the math that we do is on the difference scores. Once that column is created, we do no math whatsoever on the first two columns of numbers. In this formula, the estimated standard error, or SMD, is computed in exactly the same way as it is computed for the single sample t-test. To calculate the estimated standard error, the first step is to compute the variance, or standard deviation, for the sample of D scores. The estimated standard error is then computed using the sample variance, or sample standard deviation, and the sample size, or N. In a repeated measures design study, we're interested in whether there's a systematic difference between the scores in the first treatment condition and the scores in the second treatment condition. The hypothesis test will use the difference scores obtained from a sample to evaluate the overall mean difference for the entire population. According to the null hypothesis, there is no consistent or systematic difference between treatments. What you see in the table of data on the slide is an example that shows more of the steps involved in computing the numbers for the related or paired samples t-test. First, you subtract column 1 numbers from column 2 numbers, creating your difference scores. From that point on, all the math is done on the difference scores. So to calculate sum of squares, variance, standard deviation, and standard error numbers, you first must square each of the D values. That is shown in the last column on the slide. Remember the SS formula? You see that same formula depicted on the slide, only instead of X, you see D within the components of the formula. You would next take the SS value of 32 shown there and calculate the variance with it in the same way you learned to calculate the sample variance in Chapter 4. Sum of squares divided by n minus 1. And once you get the variance, you take the square root of that number, and you will have the standard deviation. Finally, you would calculate the estimated standard error by dividing the standard deviation number by the square root of the n. And remember that n is the number of pairs of scores. As we learned in the four-step hypothesis testing process, the first step is to state the hypothesis. Shown on the slide in notational format is how the null and alternative research hypotheses are written out. Remember that we always hypothesize about populations. That is why we see the population mean, or mu, in the notation. Notice the subscript of D next to the population mean symbol. For the related samples t-test in the null hypothesis, we are hypothesizing that there will be no average difference in the before and after treated populations. In hypothesis testing, the researcher's goal is to use the sample of difference scores to answer questions about the general population. In particular, the researcher would like to know whether there's any difference between the two treatment conditions for the general population. The alternative hypothesis states that there is a treatment effect that causes the scores in one treatment condition to be systematically higher or lower than the scores in the other condition.